Welcome again to Remilak Online Tutorial. Now before us is another question in specific heat capacity. And this question reads that the temperature of a piece of metal of mass 9 gram is raised from 10 degrees Celsius to 110 degrees Celsius when it absorbs 108 joules of heat energy. Now determine the specific heat energy of the metal in joule per kilogram per Kelvin. Alright, if you are new to my channel and if you are new to my page, please kindly subscribe to my YouTube channel, like my page, and sure you share to your friends, families, so that they will learn this. Alright, now let us start. As I've always said, whenever you encounter questions like this in physics, the first thing you need to do is to write out the parameters. Now, writing out the parameters will give you an edge on what formula to use. Now, we are given that the mass, let me write it here, that the mass of the piece of metal is 9 gram. Now, since we are having 9 gram here, take note that we are told to calculate the specific heat energy of the metal in joules per kilogram. Definitely we just need to convert this to kilogram. Now, how do we convert this to kilogram? First of all, let us recall that 1000 gram now gives you 1 kilogram. Now, in essence, always just remember that kilo here means 1000. Okay, this kilogram here, this kilo implies 1000. So if you have 1 kilogram, converting it to gram, what you just need to be just this 1 times then the kilo, which is 1000. Then you have your gram. Now if it is probably 3 gram, 3 kilogram, now it implies here that 3 times then this kilo here is 1000. Then you end up having 3 kilogram. How do we convert 9 gram to kilogram? Now, if 1000 gram then equals 1 kilogram. So what we just need to do is to divide this 9 by 1000. Since 1000 gram will give you 1 kilogram. So by dividing it, that will be 9 divided by 1000. What you just need to do is to take your decimal from here. Since it's a whole number, then your decimal is actually after the number. So you count 1, 2, and 3. Okay, so your decimal here. Then how many gaps do we have here? 1, 2. So that will be 0.009 kilogram. So this will give us 0.009 kilogram. Okay. Now the next thing here, we're not to the from. Now, since from the word from, which means it's starting from here and ending here. Since it is starting from here, so we will say that this is the initial temperature. That'll be theta 1, that'll be 10 degrees Celsius, and theta 2, that'll be 110 degrees Celsius. Okay, so and it absorbs the heat. Our heat here is 108 joules. All right, now since you've written out the parameters, now this has now helped us to recall that in terms of our specific heat capacity, we have that H equals M, which is the mass of the substance, C, the specific heat capacity of the substance, and the change in temperature, where our change in temperature signifies theta 2 minus theta 1. Alright, writing the equation, we have H equals MC, then in parentheses theta 2 minus theta 1. Alright, let us plug in these parameters into the equation. Here we have that H, which is 108, equals the mass, which is 0.009, then times the specific heat capacity. Okay, that's what we're looking for. So here you have the C, then times parentheses theta 2 110 minus what? 10. Okay, so here we have 108 equals 0.009 times C times 110 minus 10 give us what? 100. Okay, and a quick one. Now what we don't need to do here, now since this is what we're looking for, we can actually multiply 0.009 times 100, and since we are dealing with just zeros, cancel this, that is 2, take your decimal 1 and 2, so we are left with what? 108 equals 0.9 C, right? Now divide both sides by the coefficient of C, which is what? 0.9. we eliminate this, and our C and becomes 108 all divided by 0.9, and so this will give us 120 joules per kilogram per Kelvin. Final answer. I hope it is clear and well understood. All right, thank you and God bless you.